Welcome back to the channel. In this video, we are looking at the oxidation of alcohols again, but this time we're actually going to collect the product. So we know that when we oxidize an alcohol, we get a carboxylic acid. But unlike in the previous video, where we did it in a test tube, so more than one things would have been present, this time we're going to collect our aldehyde. So what is going to happen is that when the mixture is heated, the aldehyde is very volatile, so it will vaporize quickly. And so, as you know, this apparatus is a distillation one. So our aldehyde is going to run down in the tube and we're going to collect it. Alright, and then now we're going to do reflux and oxidize our aldehyde to a carboxylic acid. Alright. So that is what will happen. Alright, so let's get a little closer. And you can see our distillate right here. So that will be our aldehyde. So the alcohol is ethanoic acid. Right? So it would be oxidized to the aldehyde. We know that it can go to a carboxylic acid, but we don't allow it to go to the carboxylic acid. Right? So we did with distillation, as the alcohol is oxidized to the aldehyde, it vaporizes and we collect it. I will do the one now where we allow it to go to the carboxylic acid, and that is reflux. So with reflux, we don't allow the vapor to escape. So when the ethanol is oxidized to the aldehyde will vaporize, but in the reflux setup, it will not be able to escape. And so it will fall back into the reaction mixture, where it will be further oxidized to a carboxylic acid. So this setup right here is when you want to collect the product of the oxidation, the first product. So in the by the way, in the reaction mixture, it was ethanol and potassium dichromate, right? As you know, it would have changed from orange to green, all right? So we are just separating now the ethanol, which is the aldehyde, from the mixture. And of course, while you're watching, you can feel free to skip ahead. Alright, because this is what will happen. So, alright, I'll pause it here and then we pick up when we reach a little further. Alright, so as you can see, the process is still continuing. The mixture continues to vaporize and we collect the aldehyde on the next section. Alright, so we'll just continue to do this a little longer. And then to prove now that it's actually an aldehyde, we are going to do the valence test again, because we know that that is a test for aldehydes and we can also oxidize it. Alright. Alright, so I'm going to stop it there for now. So as you can see, here we have the ethanol. So now in the second part of this video, we are going to test our product with valence solution. Alright, so that is the distillation. So if you want to get the aldehyde from the alcohol, when you oxidize it, we will do distillation. But if you want the carboxylic acid, we're going to do reflux, which I will show you as well. Alright, welcome back again. So here I took off the aldehyde. Alright, so this is our ethanol. So I have my hot water bath here. So before I started the video, I did the test initially, and this one is the silver mirror test. And as you can see, if you had watched the previous video for the reaction of aldehydes, this one is a much better silver mirror. As you can see, it's much more it has the metallic look, a much better metallic look, as you can see. So this is with the product we have just obtained from the oxidation of the ethanol, right? I did the silver mirror test on it, and this is it. So we can see that it is an aldehyde. So we got an aldehyde. I'm going to do it again and let you see it. With the Benedict solution, we did not get, so the blue is the Benedict solution, and the other test tube, this one, a slightly light green color, that is the color change that we obtained. Alright, so not a lot of the copper ions were oxidized. Not oxidized, were reduced for that matter. But enough were reduced to give us the color change, but not enough to give us a brick red color. Alright. And I also did it with the potassium permanganate, because we know that aldehydes can be oxidized, right? And you see we got the color change. So I'm going to do it now and let you observe it for yourself. So first, I'm going to do the silver mirror test. So again, I have my solution of silver nitrate and aqueous ammonia. Alright? And I had poured out some of the aldehyde already in this test tube. Alright, this is enough. Alright. So this is the silver mirror test for our product. I'm going to move the phone closer so you can observe the actual formation of it. I'm going to video the entire process, so while you're watching, if you want to skip, yeah, you will be able to do that. So, but I'm going to show you the actual change. And I think we can see it start changing already, slightly. Yes, it is definitely changing. And you can see right up here the metallic silver atoms. You can see the silver color starting to appear. So you can see it here. Alright, so there is our silver mirror forming on the test tube. Alright, so that is a positive test for our product. So we know indeed that the ethanol, it was oxidized to ethanol. Alright, so that's our silver mirror test with our Tollens reagent, which is a solution of silver nitrate and ammonium hydroxide. So time for the next one now. Alright, so next one, I'm going to use the potassium permanganate, the drop of it. Alright. We can see that it changed from the intense purple color. And the one that was done earlier, so this one was taking a longer time. So you can see it decolorized the potassium permanganate. Alright. And as you can see, this is still going, right? Add a acid and see if it speeds it up. Alright, so just to note, remember this was the potassium permanganate, and now this is how it looks with the aldehyde. Alright, so the next one is the failing solution. This failing solution was not working, but as I had explained, failing solution, it has in copper 2 ions, and so does Benedict's solution. So the reason why it is blue is because of our copper 2 ions. So I'm going to react it again with our aldehyde. So I'm going to pour out a small amount because I need to use this for the reflux reaction. Alright, so just going to pour out a small amount because we need to oxidize the rest to the carboxylic acid. Alright, I think that's enough. I'm going to add the Benedict's solution. So we're not expecting any major color change for this one, right? We're expecting to get a green color. And in the meantime, again, you can see that the solution of potassium permanganate, it is getting clearer and clearer, or colorless for that matter. It is changing. Alright, so you can see it. Right, so again, we know that the aldehyde now would have been oxidized to the carboxylic acid. It's not changing as much as yet. And so in the meantime, I'm going to set up the reaction for reflux.